Hi friends, today let's talk about development of surfaces. When the surfaces of a solid are laid out on a single plane, the figure obtained is known as its development. This development represents the actual shape of all participating surfaces in that object. The surfaces, when bent or folded at the edges, form the solid. The knowledge of development of surfaces is essential in many industries. Let's understand this surface development concept with a simple illustration. Observe the pictorial view of a rectangular carton closed at both ends. Now imagine this box is cut along the edge AE and the sides are opened out. Observe the orthogonal front and top views of the carton. Then its developed surface view will appear as 4 equal sized rectangles, each rectangle being the size of the longitudinal side of the box. The flaps of the boxes stand out as separate squares. Here, the surface development of the carton was done with the help of orthogonal views of the object. In general, the final fabricated product is made up of various geometrical shapes. There are different methods of surface development. The parallel line development method is used in surface development of cubes, prisms, cylinders, and objects having regular lateral surfaces. The radial line development method is used in surface development of pyramids, cones, and objects having slant edges and surfaces. Normally, in case of prisms, pyramids, and similar objects, the development of surfaces involves opening out the sides on a planar surface, while in the case of cylinders, cones, and similar objects, it involves rolling out the surfaces. So let's describe the development of a prism. The hexagonal prism is resting with its base on HP. One of its sides is parallel to VP. It is cut by a plane inclined at 45 degrees to HP and perpendicular to VP. The plane bisects the vertical axis of the prism. Observe its orthogonal views. Here, trace MN of the cutting plane makes an angle of 45 degrees with HP and passes through the midpoint of the vertical axis. To develop the surface, the prism is rolled out, making its lateral surfaces lying on a plane. The line which marks the boundaries of the rolling is known as stretch out line. It is A', here. A' has a length equal to the total side length 360 mm of the prism. Next, draw line A', of length equal to prism's height, that is 150 mm, and complete the rectangle. After that, vertical points are marked at 60 mm apart and vertical lines are drawn to cut A'. These projected rectangular planes are the vertical sides of the given prism. The horizontal projectors drawn from points on the line MN meet the vertical projector lines at 1" through 1". Joining these intersecting points in a sequence gives the required developed surface of the prism. So friends, the development method was interesting, wasn't it? Let's develop some more surfaces in the next module.